Hello, in this lecture, we are going to do a few topics which were left in Legendre's polynomial, and a few lectures I have already done, and I think a couple of lectures are left now with regards to Legendre's polynomial. Okay, so we've done till now the generating function, we've done generating function, some of the recurrence relation we have seen, orthogonality relation we have seen. Today we are going to see the completeness property of Legendre's polynomial. Okay, so today we are going to see completeness property of Legendre's polynomial. So see, so we'll see the completeness property of Legendre's polynomials today. Okay, uh, so we've already studied that Legendre's polynomial of different orders, Legendre's polynomials of different orders are orthogonal to each other. They are orthogonal to each other. That is, I have written it in a different sense. I wrote like this was the orthogonality relation, that is -1 to 1 pmx pnx dx is equal to 2 upon 2n plus 1 Kronecker delta m. So this was how I would write my orthogonality relation. So this is my orthogonality relation of the Legendre's polynomial. Okay, so this is the orthogonality relation for the Legendre's polynomial. Okay, and one can see that, for example, I'll give you, I'll do all these things with an example. Let's say uh, in R square, okay, or in R square, we know that your I cap, or in fact, I'll take R cube for that matter, I cap, J cap, K cap forms an orthonormal basis vectors. Okay, what do I mean basis? Now any vector can be spanned using I cap, J cap, K cap, or I would say not right now. I'll not use the word span. So I'll use the word. Let's say any vector can be expressed in terms of linear combination of I cap, J cap, and K cap. Okay. So for example, any vector, if I want to write, I can write it as A1 I cap plus A2 J cap and A3 K cap. So what does it mean? I mean that any vector can be written in the form of in the linear combination of I cap, J cap, K cap. It means that I can use my orthonormal base. I can use my I cap, J cap, K cap in order to write any vector. Okay, so and these I cap, J cap, K cap have special property, that is I cap dot J cap or J cap dot K cap or K cap dot J I cap. All of these are 0. If I take all these like dot product for all these I cap dot J cap and all these things, and J cap dot K cap and K cap dot I cap, this will give you 0. And if I take I cap dot I cap or J cap dot J cap, or I'll take K cap dot K cap, this will come as 1. So this is what is encapsulated in this also, because we know that if m is not equal to n, then this integral would be equals to what? This integral would be equals to 0. So what I mean from this is that if m is not equal to n, then these two Pm and Pnx are orthogonal to each other. Orthogonal to each other. And if P is equal to M, then obviously this is some non-zero term, obviously not equal to 1, but some non-zero term. So in other way, they can be said to be orthonormal. They can be said orthonormal to each other. And in this sense, we define something called as completeness property. So by completeness property, we mean that, I'll write it so that, so by completeness, what should I say? We mean that any well-behaved function, any well-behaved function fx can be approximated or can be expanded, or can be approximated, I should write, can be approximated to any desired accuracy, any desired accuracy by a series pkx, by a series in pkx. So what I want to say is that if I want to write my f of x, then I can write it in terms of in terms of linear combination of pkx, because you see the these Legendre polynomial p and x, they form what? They form a set of orthonormal basis vectors. Is that clear to you? So what I want to say that I can write my f of x as some linear combination of
Yes, sir.
linear combination of pkx. Okay, now I'll use the orthogonality relation. So by orthogonality relation, we already know that pkx is orthogonal to pmx. So I'll multiply both of the side by pmx minus 1 to 1, integrate it from minus 1 to 1. So pmx f of x dx is equal to integral k equal to 0 to infinity. And there is ak here, and integration minus 1 to plus 1. Here you have pmx, you have pkx dx. Is that clear? And it is quite clear that this will give you a non-zero integral only if m is equal to k. Only if m is equal to k. So if m is equal to k, so this will be equivalent to am. This will be equivalent to writing 2 upon 2m plus 1. Is that clear? And this will be equivalent to writing minus 1 to plus 1 pmx f of x dx. Or in other words, all these constants which appear as a coefficient of Legendre's polynomial in the expansion, like f of x, if can be expanded in terms of a linear combination of pkx, there would be some constants ak's. These ak's are given by like this. So am I can write it as 2m plus 2, 2m divided by 2m plus 1 divided by 2, from minus 1 to plus 1. This is pmx, and then you have f of x, and then you have t of x. Is that clear?
Yes, sir.
Okay, so this is how you can express your like. So let us do a question and then understand a few of the past questions also, so that you'll be able to. So let us expand the following function. Following function given by f of x equals to 1 if x lies between 0 and 1, and if x lies between minus 1 and 0, it is equal to 0, in the form of in the linear combination of pkx. In the linear combination of pkx. Okay, so let us try to do it. So we already know that akx can be written as minus 1 to plus 1, and this is like f of x into pkx dx. So if this is n, so I'll write n here so that confusion not happen. Okay, and there would be 2n plus 1 divided by. So your anx is simply equivalent to writing 2n plus 1 divided by 2. And from minus 1 to 0, it is 0. So it will be from 0 to 1 only. 0 to 1 only. And this is 1, or it's simply pnx dx. Is that clear? Now, if I want to find different an, so I'll write first a naught. A naught will be equivalent to 1 over 2. Integration from 0 to 1. And a naught is simply, p naught is simply 1. So this will be, a naught will be simply 1 by 2. What would be a1? A1 would be 3 upon 2. Integration from 0 to 1. I think this is x dx. So this will be, I think, 3 by 4. Similarly, what would be a2? A2 would be, I think, 5 by 2. Integration from 0 to 1. And then I can write, what should I write? It will be 3x square minus 1 upon 2 dx. So this will be 331 x by 2. So 5 by 2 will be outside. And this is x cubed by x cube by 2 minus x. So x cube by 2 minus x by 2. So this is 1 minus 1, 0. Okay. And what would be a3? So a3 would be corresponding to, I think, a3 would be 7 by 2, integration from 0 to 1, 5x cube minus 3x square divided by 2. So this is like 7 by 4, and you have this 5 upon 4 x cube power 4 minus 3x square upon 2 from 0 to 1. And so you will get here, I think, 7 by 4 into minus आ जाएगा शायद minus, I think this would be minus 7 by 60. Okay. So overall, I know that my function f of x, which is piecewise divided, this is minus 1 if, sorry, this is 1 if x lies between 0 and 1, and this is equal to 0 if x lies between minus 1 and 0. This can be written as, I think, 1 upon 2 p naught x plus 3 upon 4 p1x. P2 is x is not there, so minus 7 upon 16 p3x, so on and so forth. Is that clear?
Yes, sir.
Okay. A few more questions and then we'll finish this topic off. Okay. Okay. What do you think would be expansion of expand f of x equal to x square in a series of the form summation k equal to 0 to infinity ak pkx. I'm giving you 2 minutes. You try to do this and then I'll do it for you. Okay. So what do you think the answer would be to this? So I can write my x square. So now here you can use some trick also, because you know that after all these pkx are ultimately polynomials only, right? So what you can do, you can expand your pkx, like you can take both side expansions. You can write x square can be written as a naught, p naught is 1, a1, p1 x is this, a2 is 3x square minus 1 upon 2. Okay, and then higher order terms would obviously contain some cubic terms and all those things. So obviously this a4 no doubt would contain some term in x to the power 4 and then some term in x square also. But understand that there is no as such term in x to the power 4. So your a4 would be 0 and your a3 would be 0. Is that clear? You can take this integration technique also. I have no issues with this. But at times you can also use this. मतलब जब तुम्हें पता ही है already after all, these are both sides, they're polynomials only. So this is something that we can use. Okay, so probably there may be a mistake here. I think a3 should be 0. Why a3 should be 0? Because your x cube is 0. However, there is a linear term. You can think that what about, so understand that there is no such term here. See, there is no such a cube here, x cube here. So this is one thing that we can do. And this is x square. And from here, I'll get a naught minus a2 by 2 plus a1 plus 3 by 2 a2 x square. So from here, I can see that my a2 is equivalent to 2 upon 3. And if my a2 is 2 by 3, then my a naught would be equals to 1 upon 3. And my a1 would be equal to what? 0. So what I can do, I can write my x square as a function, as a linear combination of some Legendre's polynomial, which is equivalent to 1 upon 3 p1x plus 2 upon 3 3x square minus. Is that clear? Okay,
Yes.
is that clear? Okay.
Yes.
Now I'm giving you a question. If f of x is a polynomial, if f of x is a polynomial of degree less than n, degree strictly less than n, strictly less than n, so not less than equal to neighborhood, strictly less than n, then the value of -1 to +1 f of x p n x dx would be equal to what? What do you think the answer would be for this? So let us assume that f of x can be written, the degree of highest degree of f of x is, let's say, a. What you can say, degree minus first degree is the highest degree appearing in the Legendre's polynomial. So f of x can be written as, I think I'll write it as, let's say, a naught plus a1 x plus a2 x square dash 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 an a k x ki power k. And let us say this fx is of degree k. Fx is of degree k, where k is strictly less than n. Is that clear? Okay.
Yes, sir.
Okay. Now, since it is also, you can see that your एक moment, I'm just लिख लेता हूँ. Just give me a minute. At least expired. So okay. So now you know that your p1x is a polynomial, is a linear function. Your p2x is a quadratic function. p3x is a cubic function, so on and so forth. So one can understand that if my f of x is having highest power x ki power k, so what all I can do is I can just write my f of x as a naught p naught x, a1 p1x plus a2 p2x, and at the last I can only go till ak pkx, because if I go till pk plus 1x, since there is no such term in x ki power k plus 1, so your ak plus 1 would be 0. So this is the last thing that I can do. The polynomial can be expressed as a naught p naught x, a1 p1x, a2 p2x, and ak pkx. Why? Because since there is no term in x ki power k plus 1, you should understand that your pkx would contain x ki power k. There would be other terms as well, but I'm not concerned about it. But pk plus 1, x would no doubt contain some lower order terms, but it also contains x ki power k plus 1. And on the left hand side, if I say that my f of x has of degree k, then I do not have any term in pk plus 1, so ak plus 1 and all the other terms would go to 0. So this is how I can express my f of x in the linear combination of Legendre's polynomial of different orders. Is that clear?
Yes, sir.
Okay. Now let us take -1 to +1 f of x. This is what was asked now. P and x is equals to -1 to +1 a naught p naught pn dx plus -1 to +1 a1 p1 pn dx dash 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 -1 to +1 ak pk pn dx. And you know that your k is less than n. So this integration would go to 0, this integration would go to 0, this integration would go to 0 because k is not equal to n any day. So all these things would go to 0. So overall answer would be what? 0. Is that clear?
Sir, how that integration goes to 0?
Okay. So understand this thing that -1 to +1 pmx pnx dx equal to 0 if m is not equal to n. So n is not equal to 0, n is not equal to 1, even k is not equal to n. Why? Because k is strictly less than. Are you getting my point? So all these values are less than k. a1 a2 a3 ak तक सारी values क्या है? ये सब k से छोटी है और k खुद किससे छोटा है? k is less than n. So all these values can never be equal to n. Is that clear?
Yes,
देखो
sir.
इंडेक्स
A0, A1 ये सब तो कांस्टेंट्स है ना वैसे.
ये ए नॉट ए वन तो कांस्टेंट है. व्हाट आई वांट टू से, तुम ये देखो पी नॉट पी एन डी एक्स इंटीग्रेशन फ्रॉम -1 to +1 ये 0 नहीं आएगा. ये 1 कब आएगा? ओनली इफ n इज इक्वल टू 0. और अगर n 0 हो गया, इफ n इज 0 देन n शुड बी लेस देन k. दिख रहा है? ये नहीं समझ में आया.
Yes, sir.
अरे
Yes.
बेटे देखो ये डिग्री का मतलब क्या होता है? highest degree appearing in the polynomial. So a0 a1 a2 all these are less than k. So highest degree appearing in f of x is k. So k is the highest one. So k 0 1 2 3. So k is the highest coefficient appearing in the f of x. So obviously 0 1 2 all these will be less than k. Now -1 to 1 p naught and pn dx. So this will be a non-zero term only if n equal to 0. And let's say if it is non-zero, then n should be equal to 0. अगर n 0 हो गया, इसका मतलब since n equal to 0, so it should be less than k, which is not the case. We know that n is greater than k. Contradiction आ गया ना? नहीं समझ पाए बेबी?
हाँ सर, समझ गया सर. मेरे को ये डाउट है कि -1 to 1 इंटीग्रेशन एफ एक्स पी एन एक्स हमें उस फंक्शन को लेजेंडरी पॉलिनोमियल की टर्म्स में बेसिस में मतलब लिखने देता है ना. -1 to 1 इंटीग्रेट एफ एक्स पी एन एक्स ये वाली टर्म सर.
So, ये पूछ रहे हैं सर लेफ्ट हैंड साइड.
हाँ जी.
देखो
हाँ जी,
ये चीज
रेफरेंस.
पहले ये समझो कि लेजेंडर्स पॉलिनोमियल में जैसे p1x है तो वो लीनियर फंक्शन होता है, p2x क्वाड्रेटिक फंक्शन होता है, p3x क्यूबिक फंक्शन होता है. हमने माना कि f of x जो है इट इसमें लिखा है if f of x is a polynomial of degree strictly less than n. तो मान लिया कि इसकी डिग्री k है. So let us consider that my function f of x which is a polynomial has a degree less than k. Has a degree k which is less than n. ठीक है, which is strictly less than n. ठीक है, तो I can write my f of x as a0 plus a1x plus a2x square plus ak xk. Is that clear? जैसे यहाँ पे किया था कि
यस सर,
I
यस
wanted
सर.
to write my x square in terms of different orders of pk, so I expanded till p to a2 only ना. a3 क्यों नहीं किया? क्योंकि I know that x क्यूब का कोई टर्म है ही नहीं यहाँ.
यस सर.
ठीक है, तो डिग्री का मतलब ये होता है कि उससे ऊपर कोई टर्म नहीं होता. तो खुद सोचो ak plus 1 का टर्म होगा ही नहीं. So what I can do, I can expand my function f of x as a0 p0 a1 p1 a2 p2 ak pk and understand that k is less than n. So जब k less than n है इसका मतलब k can never be equal to n. Is that clear?
यस.
ठीक है. Now what I want to say is this -1 दोनों साइड में ना p and x मल्टीप्लाई कर दिया. This is what was asked. -1 to 1 f of x p and x ये पूछा जा रहा था आपसे, इसका इंटीग्रेशन पूछा जा रहा था. ठीक है, तो मैंने क्या किया, -1 to 1 p and x दोनों साइड मल्टीप्लाई किया. p नॉट p n दिस वुड बी 0 बिकॉज n कैन नॉट बी इक्वल टू 0. बिकॉज इफ n इज इक्वल टू 0, अगर n 0 हो गया देन k वुड बी ऑब्वियसली ग्रेटर देन. देखो ना ये k तो इससे पहले है, ये तो हाईएस्ट पावर है ना. आई एम गेटिंग माय पॉइंट.
यस सर, यस सर.
अगर n 0 के बराबर हो गया तो k विल बी ग्रेटर देन n, which is a contradiction. So overall all these terms would go to 0. Even k cannot be equal to n because k is less than n. So this integration would also go to 0 by orthonormality relation of Legendre's polynomial. So overall, all these would go to 0. So 0 plus 0 plus 0 anytime would give you 0 anyway. Is that clear?
Yes, sir.
Okay. Chalo, good enough. So we'll do a few more questions on this concept and then we'll finish this chapter at least now. Chalo, try to do this question so that if you are able to do it. ठीक है मतलब इसमें ज्यादा डिफिकल्ट क्वेश्चन यू विल नॉट फाइंड इन एग्जाम सो एक दो काम करते हैं एग्जाम के क्वेश्चंस भी कर देते हैं सो दैट you'll be able to see that what is asked in exams. Okay, so we'll finish this topic of today, and from tomorrow probably we'll take another polynomial, that is Hermite polynomial. So you'll find that Hermite polynomial is asked in is used in generally statistics and also used in quantum mechanics. So wherever you will find that quantum simple harmonic oscillator, you'll find that your solutions will end up into Hermite polynomials. Okay, so let us do that also. Just give me a minute. Meanwhile, I'll find the question for you. Okay. So question says, there was a question somewhere. Okay. So question says, ये तो बड़ा simple सा है. I'll write it somewhere. So let f of x equals to 1 plus 5x plus 3x square be written in linear combination of Legendre's polynomial. Okay, such that I can write my f of x is equal to summation n belongs to natural, n equals to 0, so we what's up, sorry, n cn enx. We have to find the value of c. Okay, I think I've done this question previously, but let us do it all over again. So how to do this? I'll write 1 plus 5x plus 3x square as a naught plus a1 x plus, sorry, c2, c1 and c naught, sorry, c2, and then I will write 3x square minus 1. Is that clear? So eventually I'll write c naught minus 3 c2 by 2, it is 1 plus 5x plus 3x square. So plus c1x plus 3 upon 2 c2x square. So clearly your c1 is 5. Your c2 is, I think, 2, right? So if you compare, c2 is 2. And your c0 minus 3 would be equals to what? Because of c2 is 2. मैंने इसमें कोई गलती तो नहीं करी, चेक करूं. 3c2 नहीं आएगा ना, माइनस c2, सॉरी, ठीक है, c2 by 2 ही आएगा, तो this will be 1. So your c0 should be equal to 2. Is that clear? ठीक है, ये एग्जाम में पूछा हुआ है, so it's an easy question from net exam. Okay, so such questions are asked mostly, मतलब ये इसी तरीके से क्वेश्चन पूछेंगे, तो उससे सारा कुछ नहीं पूछा जाएगा. Okay, is that clear? चलें आगे क्वेश्चन और करें. Okay, one question was asked not exactly on Legendre's polynomial, but it was a maxima minima question, but somehow it appeared in the GIST exam. So let us do that also. Okay, so let us do that also. Well, somehow it is not a question of okay, so this appeared in GIST exam also, and again in NET exam. So both of like this is not a question for Legendre's polynomial. This is a simple question for maxima minima. So you can take this question as a question for maxima and minima. So it says that if Pnx is a polynomial of degree n, then the maximum number of extrema means या तो maxima या minimum. Extrema of the function pnx into e की power minus x square is, ये पूछा. So this was asked in just exam, I think, and it was also asked in net exam. So like these are very easy questions. So let us do this question. Now, just exam wala bhi question मैं बता देता हूँ. What was asked in just exam also. Let us do that also. It was given, what is the, this was asked in just exam. So this was asked in net exam, and this was asked in just exam. The question that I'm right now writing. What is the maximum number of extrema of the function f of x equals to pkx e की power minus of x की power 4 upon 4 plus x square upon 2, where x belongs to R, and pkx is an arbitrary polynomial of degree k. It is an arbitrary polynomial of degree k. Okay. So how to go about it? So कैसे करें इसको? पहले वाला क्वेश्चन पहले पकड़ते हैं. So question says that if p and x is a polynomial of degree n, then the maximum number of extrema of this function. So in any case, this is a continuous as well as differential function. So the necessary condition for existence of extrema, that is minimum or maximum, existence of extrema is what? That your f dash x naught must be equal to 0. So if let's say my x naught is an interior point and there exists an extrema there, extrema मतलब समझ पा रहे हो, मतलब maxima या minimum. We don't know about the second derivative, but at least one thing is clear, that if my function is differentiable, like if my function can be differentiated, then my f dash x naught must be equal to 0 at that point. Is that clear? Yes or no?
Yes, sir.
Okay, good enough. So if that is the case, then it implies that my d by dx of pnx into e की power minus x square must be equal to what? 0 at the point of extrema. At the point of extrema, let's say x equal to x. समझ पा रहे हो मेरी बात?
हाँ जी सर. Yes.
ठीक है जी. इसका मतलब क्या होगा? It will be like pn dash x naught, और ये x naught क्या है? Extremum point. So x naught is the points of extremum. So they are point of okay
n
by
plus 1
extremum.
होगा.
हाँ बेटा.
n plus 1
हाँ,
होगा
right,
क्या सर
n
इसका?
plus 1. And then there would be plus, I think pn x naught, and then there would be minus 2 into x into e की power of my x naught into e की power minus x naught square. Is that clear? This should be equal to what? 0. Is that clear, बेटा? ये चीज समझ में आ रही है?
हाँ जी सर. Yes.
Okay. Now, what I can do, I can take e की power minus x naught का square common out, and I will get what? I will get simply pn, and I'll take negative also common out. So this will be like x naught into pnx plus minus pn dash x not equal to 0. Okay. So what is this? This is some qn, है ना? This is a polynomial, isn't it? पहली बात ये polynomial होगा. And what would be the degree of it? If you see, this is x naught. This is pnx is a degree, and pnx highest degree is, and there is x naught multiplied. So overall, this will be a polynomial of degree n plus 1, isn't it? So this will be a polynomial of degree n plus 1, and e की power minus x naught का square cannot be 0. This implies that this is the case, and I know that if there is an n plus 1, if there is a polynomial of degree n plus 1, the maximum number of roots can be what? N plus 1. So there can and maximum number of roots here correspond to what? Here it corresponds to maximum number of extremum. ये पूछा जा रहा था. Maximum number of extremum would be what? N plus 1 in this case. So this was asked in net exam. And see, this particular question was asked in JEST exam in 2015. And this particular question was asked in, I think, 2018 somewhere, I think, in net exam. So the key to success in all these exams is that if you are able to do all the previous year question, but with all, जिसको कहते हैं ना brain लगा के, ऐसे नहीं कि बस कर लिया. So I've seen people doing all these questions, still they don't make the cut. One thing I can say that they are unlucky. And other thing is that they don't keep things in mind. मतलब इसको भूलना नहीं है करके. पता चला पढ़ते गए और भूलते गए. Then what is the use of reading anything? इसलिए मिनिमम कंटेंट करो और वो अच्छे से करो. और ये जो मैं बीच में करा रहा हूँ ना डिफिकल्ट चीजें, जैसे मान लो मल्टीपोल एक्सपेंशन में डिफिकल्ट बहुत ज्यादा ऐसा लग रहा होगा कि जैसे एग्जाम जैसा तो नहीं कराया मैंने, बट अंडरस्टैंड कि ये सब चीजें ना तुम्हारे इंटरव्यू में फंसोगे. सो इफ एट ऑल इवन इफ यू क्लियर द एग्जाम देन इंटरव्यू में मतलब यू विल नॉट बी एबल टू गेट थ्रू. सो देयरफॉर because you people are in MSc or at least cleared MSc, so at least you know how to adjust the rigor when it comes when your exam comes. So when your exam comes, you don't have to go through derivation, but uska ek idea leke then. So what do you think what do you think an answer to this would be? What is the maximum number of extrema of the function f of x is equal to pkx e ki power minus x e power 4 by 4 plus x square by 2? However, these questions are not exactly related to Legendre's polynomial, but somehow I thought I should do it right now, so I did it right. What do you think an answer would be to this?
So k plus 3.
K plus 3. K plus 3. Okay, okay. The same thing, same step you will do, and you will be able to understand. So if I differentiate it, what I'll get? I will simply get pk dash x. It's just question. Okay. So for existence of extrema, the derivative must be 0. So this is minus x e power 4 by 4 plus x square by 2, and then minus x cube plus x, and then you will have pkx e ki power minus of x ki power 4 by 4 plus x square by 2. And this entire thing should be equal to 0. And what does it imply? It implies that x cube into pkx minus x ki power plus and minus pk dash x must be equal to 0, because this cannot be 0. It implies this is a polynomial of degree k plus 3. And maximum number of roots, or maximum number of roots for a polynomial of degree k plus 3 can be k plus 3. So maximum number of extrema in this case can be k plus 3. Is that clear?
Yes, sir.
So I think this is quite enough for today. Probably I'll take another class, and each class may we'll try to finish whatever we can do with regards to Legendre's polynomial. Okay.
Yes, sir.
Okay.